Hey guys, HackerSploit here, back again with another video. Welcome back to the penetration testing bootcamp, more specifically the Windows privilege escalation section of the bootcamp. In this video, we're going to be concluding the Windows privilege escalation series by taking a look at access token impersonation, both through the RoguePotato executable or technique and PrintSpoofer. And we should be done with this, and we can then focus on web app pen testing. With that being said, as I said, if you want to follow along or get started with this series, you can take a look at the free room on TryHackMe. It's called Windows PrivEsc. And I would recommend, if you're a beginner, then just start off from our first video within this particular series. So if you take a look at the HackerSploit YouTube channel, under playlists, there should be a playlist called Windows Privilege Escalation, where all of these tasks and the video walkthroughs for them are sorted, based on when I released them, and you can go through them. So we're going to be concluding with access token impersonation. Now, before we actually, get started, I just want to point something out, that access token impersonation, the process itself is fairly simple to understand, right? And I have explained what access token impersonation is, and what it essentially entails, and the way it sort of ties into privilege escalation, right? So a Windows access token is essentially responsible for identifying and describing the security context of a process or thread that is running on a system. So a simple way of thinking of it is an access token is essentially like a temporary key akin to a web cookie that provides users with access to a system or network without having to provide the user credentials each time a process is started, or a system resource is accessed. Now, Windows access tokens are a very important element of the authentication process on Windows, and are created and managed by the LSAS process, or the Local Security Authority Subsystem process. And the way they're generated is, first, they're actually generated by the WinLogon process, and I'll get to the different types of the different security levels of impersonation tokens. But access tokens are generated by the WinLogon process, and they're created whenever a user logs in successfully. So whenever you start up a Windows system, you have the login screen that is facilitated by WinLogon. So when you essentially type in your username and password and hit enter, an access token is created. And this access token includes the identity and the privileges of the user account associated with the thread or process, right? The token is then attached to the user init.exe process, after which all child processes that are started by that user will inherit a copy of the access token from their creator, and will run the privileges of the same token. So what that means is, access tokens are essentially useful in describing and identifying the the security context of a particular process or thread. So why is this important? When you log into a Windows system, WinLogon will generate an access token, and that uniquely identifies your session, right? And that access token contains your user privileges, or the privileges associated with that account. So whenever you create a new process, like you launch Google Chrome on your desktop, that user init process will essentially, will create Google Chrome, but it will that process will inherit a copy of the access token, which again identifies you, and it essentially is used to separate processes by their privileges. So, if I, launch an account with a standard user that's non-privileged, then that, access token describes the security context of that process. And that's very, very important. Now, where does impersonation come into play? Well, impersonation is essentially the process of identifying access tokens on a Windows system that you can impersonate. And when I speak of impersonate, I mean that you can essentially inherit. So the objective here is to find an access token that belongs to a privileged user account on the system, or an access token, for the anti-authority system, that has anti-authority system privileges. And when you inherit it, or when you impersonate it, if that's a better word, you essentially obtain the privileges associated with that access token. Now, access tokens have multiple security levels, which I'll be explaining, right? And the two main ones are going to be the impersonate tokens and the delegate tokens. Impersonate level tokens are created as a direct result of a non-interactive Windows logon, typically through specific system services or logons. And then you have your delegate tokens. The delegate tokens are typically created through an interactive logon on Windows, primarily through a traditional login when you sit down on a computer and type it in, or via RDP. So just keep that in mind. One additional thing you need to keep in mind is that the delegate tokens are, essentially pose the largest threat, as they can be used to impersonate tokens on any system, right? And again, I'll probably be exploring this in the future, but for now, because we're only dealing with one system, it's very important that you understand that. So let's get started with token impersonation with RoguePotato. Now, RoguePotato is sort of a newer rendition of Juicy Potato and Rotten Potato, of which I've actually covered, and those were the two techniques that were typically used. However, they were patched. So on modern Windows systems, so Windows 10, Windows Server 2016, and Windows Server 2019, RoguePotato seems to be the answer. Now, the way it works is slightly confusing if you're not familiar with how, a Juicy Potato or Rotten Potato works. But I'll try and explain it my best, because the process is fairly complex, right? Now, in order to perform this technique, you need to set up a redirector on Kali to essentially redirect traffic that will be incoming on the Kali Linux system on a specific port, more specifically the default RPC port, which is 135. So it redirects that to the Windows target system on port 9999. That can be anything, but that's the default port used by the RoguePotato executable, right? And so you need to have SOCAT installed. Now, I will be making a video that explains how SOCAT works. But firstly, let me just explain the actual infrastructure here. So as per the documentation within this task, we actually need to obtain an RDP session as the admin user, which I've already done. So in the previous video, we got the admin credentials, and I've logged in via RDP, and I'm currently the admin user. So there we are. You can see I'm admin. And as it says right over here, we're going to simulate getting a service account shell by logging into RDP as the admin user, starting an elevated command prompt, and using psxx64 to trigger the reverse.exe executable you created with the permissions of the local service account. So why local service account? Well, this is one of the main requirements of access token impersonation. Is in order for you to impersonate another access token on a Windows system, you need to have the SE impersonate privilege. So you can see that I currently have a Meterpreter session on the target system, and I currently have access as the non-privileged user account here. So if I typed in, get privs, you can see that this account does not have the SE impersonate privilege, which means we cannot really, perform any impersonation from this user account. That's just the way it is. However, from the admin account, if I just open up a command prompt here, let's see whether the admin account has, the actual privilege. So who am I priv? You can see that it doesn't have it. However, if we bypass UAC or run something as administrator, so let me just say CMD here, and I say run as administrator, there we are, and I say who am I priv, you can see that in this case, then we do have SE impersonate, the SE impersonate privilege, which is enabled, right? And, if I say who am I here one more time, you can see currently admin, but that's really not the case unless we run a Meterpreter payload with the admin credentials, or we run it as administrator. We would obtain an elevated Meterpreter session, but that's not the technique that we're exploring here. Right, so in this case, then I'm not really criticizing this particular room, but I thought it would be much better to have a task that focused on bypassing UAC, as it would make sense in this case that, once we were able to authenticate with the target system as the admin user, we could use a tool like UAC me to bypass UAC and, obtain an elevated session. However, that's not what we're focused on. Right, so we have access as the admin account, and the first thing we need to do is set up a SOCAT redirector. And the way this works is you need sudo privileges or root privileges in order to essentially listen on a particular port, or set up a listen on a port and then redirect it to the IP address of the target system on port 9999. So you're essentially saying whatever traffic comes from the target system, on port 135, I want you to redirect it to the target system to port 9999. So let me just copy that there, and let's set up the socat redirector. So I'll paste that in there, and let me just type in my password here. There we are. So it's running. It will not provide you with any output. So that is done. The next step, as it says here, is to again utilize the reverse.exe, or the reverse the interpreter payload that we generated with MSF Venom, and we need to execute it with psexec with NT-authority local service, the local service privileges. The reason we're doing that is when we obtain this interpreter session, it'll still be unprivileged, but it should have the SE impersonate privilege. Now, as far as I know, and this is with my very I would say very basic understanding of the privileges you typically associate with, NT-authority local service permissions, or the, local service account, it should have the SE impersonate privilege, although in some cases that might not be the case based on the Windows system. So enough talking. What I'll do is let me upload the reverse.exe that I generated here, and I'll just head back into my interpreter session. So I'm currently pwd, I'm currently under the C drive. I'll navigate into the temp directory here, and I'll say upload documents, tryhackme, Windows privesc, and reverse.exe. All right, so I'll upload that into that folder. What we then need to do is set up the actual listener. So under this directory, I've put all my resource scripts under a folder called resource scripts, and I have the handler resource script. So I'll say msf console r handler, and this has been configured with the correct IP address, my Kali Linux IP address, and the port that I specified when I was generating the payload with MSF Venom. So I'll hit enter, and we'll give this a couple of seconds. And then, as it says within the documentation here, is on the Windows system via RDP that we have admin access on, we need to right click and open up a command prompt as administrator, and then use psxx64.exe to trigger the actual reverse shell. However, we need to modify this, this argument slightly here. So let me just open up a text editor, and let me just zoom in so you can actually see what's going on. There we are. Okay, so what I'll do, let me just resize that there. We're going to change this to the temp directory because that's where I uploaded reverse.exe, and that looks fine. So I'll just copy that there. Now on the Windows RDP session, I'll open up a command prompt, run it as administrator, and I will navigate to the privesc directory. So cd root of the C drive, privesc, and we should have psxx64.exe. Yes, we do. So I'll just say psxx64.exe, and I'll paste in the other arguments. There we are. So let me make sure the listener is actually, whether the handler is actually running. There we are. Started reverse TCP handler. Fantastic. So I'll hit enter, and we should receive a interpreter session with the NT-authority local service, privileges, and let's see whether that works. I've just hit enter. There we are. So it's sending the stage, and we'll give this a couple of seconds, and this interpreter session should have the SE impersonate privilege. So there we are, interpreter session opened. I'll say get use ID. There we are, NT-authority local service. So get privs. There we are. So we have SE impersonate, the SE impersonate privilege. Fantastic. So what we need to do now, and I'll explain how RoguePotato works a little bit more here. Once that is done, you can see it's going to say now in the local service reverse shell you triggered, run the RoguePotato exploit to trigger a second reverse shell running system privileges. Update the IP address with your Kali IP accordingly. So we need to execute roguepotato.exe, specify our Kali Linux IP, and specify the path to another reverse shell or interpreter payload that we've generated. And then we're going to set the listener on port 9999, right? So what's happening here, let me just open up the actual RoguePotato GitHub repository. As you can see, it just gives you a very brief description as to how it works. Just another Windows local privilege escalation from service account to system tool or exploit. If you want to learn more about it, you can take a look at this fantastic write-up, which I've actually gone through, and hopefully I'll be able to simplify it for you. But if you're a beginner, this might be, there's quite a lot of jargon that you might not understand here. But I'll try and explain it as simply as I can. So I have a couple of notes here that sort of lay out what's happening. So when we run the RoguePotato exploit or executable, it will essentially tell the DCOM server on Windows to perform a remote OXID query on our Kali Linux IP, and we will specify that IP address, right? Now, on our Kali Linux IP, we of course have set up the SOCAT listener on port 135. That will redirect the OXID resolutions or the requests to the fake OXID RPC server that's running on port 9999. That is created by the RoguePotato exploit, as you can see here. Let me see if I can show you that here. Just give me a second. There we are. So you can see that if you take a look at the examples here, that the default port is 9999, and we've already set it up with SOCAT. So what I'm going to do here is let me just explain what's going on a little bit better. So as I said, on our Kali Linux system, we set up the SOCAT listener on port 135 to receive the actual OXID requests, and then we will forward them or redirect them, or SOCAT will redirect them to the fake OXID RPC server. Now, what happens after that is fairly complex. So the RoguePotato, the fake OXID RPC server created by RoguePotato will implement the resolve OXID server procedure, which will then point to a controlled named pipe. The DCOM server will then connect to the RPC server in order to perform an interface call, and that is done by connecting to the named pipe. Furthermore, an authentication callback will be performed, and that essentially allows us, us to impersonate, through the RPC impersonate client call, right? Now, the RoguePotato exploit has the functionality to essentially obtain the process ID of the RPCSS service, which is the RPC service, right? And so what it'll do is it'll open the process and then will identify the handles, and for each of these handles, it'll try to essentially duplicate it and get the type of the handle. And if it gets the token handle, or if the handle type is token, then the owner is system. It'll try to impersonate it, and it'll launch a process. It'll launch a process with the impersonated token, right? So as I said, that's really what's happening in the background. It might be a little bit confusing. I hoped that this task would essentially elaborate on how it works, but I'll probably have another video explaining it in depth, because it is quite complex to understand. It took me, a couple of hours to actually understand what's going on. However, we need to upload the second shell that I generated. The reason for that is primarily because reverse.exe has been configured to use port 1234, and we need this session here because this is the this meterpreter session as the anti-authority local service. We currently have access as anti-authority local service with the SE impersonate privilege, and we need access to this one. So what I did was I created another payload with MSF Venom, and I just called it shell.exe, and instead of connecting to port 1234, it connects to port 1245. So all I need to do really is head over back into my resource scripts directory and modify this handler resource script and just change the L port to 1245. I then need to upload shell.exe. So I'll just head back into my standard non-privileged meterpreter session, and I'll just use the previous command, and I'll just say upload shell.exe. Okay, there we are. Fantastic. So now let me make sure I have everything good to go. Let's say MSF console r handler.rc. We'll give this a couple of seconds, and we can then take a look at this command here. So we need to execute RoguePotato, replace this IP with our own IP or our Kali Linux IP, and modify it slightly. So let me just paste it in my notepad here. So I need to get my Kali Linux IP. Let me just open up a new window here. And this is my IP address there. So I'll just close that now. And I can change this here. So let me just get rid of that there. There we go. And the new shell is under the temp directory, and it is called shell.exe. Shell.exe, and we set the listener on port 9999. Now this might be an issue if Windows Firewall is enabled. I'm just pointing that out. And I have had issues with it. So again, this is not really bulletproof. Okay, so that is done. We have the handler, we have the listener there. We're going to listen for our new interpreter session that should have anti-authority, system privileges. One thing that I wanted to do is, let me just load the incognito module on the anti-authority local service interpreter session. And if I say list tokens you can see we have 2 delegation tokens, but no, we don't have any impersonation tokens, which is fine. However, as we know, even if we were to essentially impersonate the admin token here, it would really not change our privileges in terms of what we could do, unless we bypass UAC, which is why I keep going back to that. Anyway, what we now need to do is, let me open up a shell here, and I'll navigate to the root of the C drive under priv-esc, and we should have the RoguePotato executable here. We do. All right, so RoguePotato, if I can type potato in correctly, RoguePotato.exe, and I'll paste in the arguments there. So that will connect to our Kali Linux system, and it's going to execute the file called shell.exe in the temp directory. And yeah, so I'll hit enter, and it should actually give us a series of messages here. Okay, so there we are, starting RoguePotato, creating the Rogue OXID resolver thread, creating the pipe server thread, creating the trigger decom thread, listening on the pipe, calling the coget instance from iStorage with the CLS ID. This is the CLS ID here. I'll be explaining that probably in another video where I'll be diving deep into RoguePotato. Starting Rogue OXID resolver RPC, listening on port 9999, as I said there. Security callback RPC call, server live 2 RPC call, and then of course you can see the resolve OXID 2 RPC call. This is for us, and it's going to again, there we are, say client connected, got the system token, fantastic, and it tells us that something went wrong. Interesting. So I wonder what went wrong here. That is very interesting indeed. So let me just take a look at that one more time, because I believe, yeah, this is the one that has the SE impersonate privilege. I believe everything, the file with is under temp directory there. We have shell.exe. I'm not really sure why that might be causing an issue, but let's take a look at the documentation. Yeah, I'm not really doing anything incorrect there. So RoguePotato, yeah, not really doing anything wrong, but let's try and run that again. So we will say, we'll go back into this here, and I'll say RoguePotato.exe, paste that in there. Okay, so it looks like it worked now, finally. So we should get there we are, sending stage, and this should have anti-authority system privileges. So get use ID, and there we are. So we've been able to elevate our privileges via access token impersonation. We're not yet done. We still need to answer a couple of questions. So name one user privilege that allows this. Yeah, that's fairly simple. So that is SE impersonate privilege. So submit. Yeah, well, that's correct. The name another user privilege that allows this exploit to work. I believe it's the, let's take a look at this standard session there. Who am I? Priv. I believe it's the SE assigned primary token privilege. So that, yeah, that replaces a process level token. So let me just, let's see. I'm pretty sure this is the answer. Yeah, it is. Okay, fantastic. So that is done. Let's move on to the final one, which is much more simpler. And we don't need to go through the step of obtaining a interpreter session with anti-authority local service privileges, right? So if we take a look at the PrintSpoofer GitHub repository, you can see that, pretty much just tells you what it does from local network service to system. So yeah, you do need access to a local network service, and you can use a PrintSpoofer by abusing the SE impersonate privilege on Windows 10 and Windows Server 2016 and 2019. All right, so you can see how it works here. It's fairly simple. They give you, really cool instructions as to how it works. So you can see it gives you a very brief description right over here that I really like. So provided that the current user has the SE impersonate privilege, this tool will leverage the print spooler service to get a system token and then run a custom command with the create process as user call. So yeah, it's fairly simple to understand, much more simpler than, utilizing RoguePotato. So what do we need to do now? Let's go ahead, and we still need access to this interpreter session. The privileged one we can get rid of, so I'll just say exit, and I'll just set up the listener again. So there we are, MSF console, our handler.rc. If we go back into the try hack me room here, you can see that we need the actual interpreter session with anti-authority local service permissions or privileges. We then need to start up another Kali listener. Now in the local service reverse shell you triggered, run the PrintSpoofer exploit to trigger a second reverse shell running with system privileges. Update it update the IP address with your, I don't think we need to do that here. Yeah, because there's no real need to specify an IP address, because we can just customize this here. So we're executing shell.exe. So that's under temp, shell.exe. We need to execute printspoofer.exe. So I'll navigate back in here. So I say dir, and we are looking for printspoofer, not spooder, printspoofer.exe. There we are. That'll execute shell.exe in the temp directory. Hit enter. All right, found the privilege, SE impersonate, named pipe, listening, create process as user, okay. There we are. We get the interpreter session, get use ID, enter authority system. Okay, fantastic. So we've been able to elevate our privileges, through the use or by leveraging access token impersonation. As I said, if you want a better understanding, firstly, of access token impersonation now and how it works, please take a look at some of my earlier videos. I'll probably put one in the description section that explains it. Those will essentially cover how rotten potato and juicy potato works. Once you understand those two, then RoguePotato will be much simpler to understand. So that is done, and we have finally completed the Windows Priv-esque room. I know that took a while. Apologies, guys. But yeah, I think this is a good step in the right direction. We're almost done with the penetration testing bootcamp. We're going to be winding up with the web app pen testing series, and then I'll probably cover a few more mini series on stuff that we haven't covered yet. But next, of course, will be Linux. So Linux post-exploitation will cover persistence, privilege escalation. I already uploaded the first video of Linux defense evasion. So yeah. The final task is fairly simple. I've already covered most of these tools like WinPeas and PowerUp. I'll also be covering others in their own individual video, just to do them justice. But yeah, that's pretty much it, guys. Thank you very much for watching. If you have any questions or suggestions, let me know in the comment section. If you want to reach out to me personally, you can do so via my Twitter account. The link to that is in the description section. You can also reach out to me via the HackerSploit Discord server. The link to that is also in the description. If you want to support the channel, you can do so by, taking a look at our Patreon page. And thank you very much for the support, guys. I really, really appreciate it. And I'll be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.